Let's move on to existing boundaries. First of them is language syntax. For example, if we would like to overload an operator, it's a special kind of polymorphism where different operators and different classes can define own rules, how we can, for example, add two different objects, or we can define special rule to multiply matrices. Then we want to have a power on PHP language to use operators for objects. But if we try to use operators like addition, multiplication with objects, unfortunately we will see that PHP is not capable, and it's a clear boundary because it's a language construction and the object of class matrix could not be converted to number. Unpleasant effect that if we try to use it with modern PHP, it even produces a result which can be 3, which is totally wrong. And modern version of PHP, which will be version number 8, produce a fatal error about type error, which is more good because we can clearly see that we cannot perform multiplication of matrix with an integer number. And yes, this is what we have, is PHP doesn't support operator overloading for objects, but for userland. Next boundary is famous OpenClosed Principle. If we want to extend our class, it's open for extension, but if we try to modify it, then it's closed. And if class is closed or final, then it's obvious that we if we make it, if we create a child from this class, it won't be possible to extend it, and we will receive a fatal error like class child may not inherit from final class. It's a second boundary, and it prevents us from, for example, mocking a final class for testing, and sometimes this can bring problems, and we need to avoid them. One more boundary is immutable PHP structures. As you know, PHP is a kind of interpreter, but at the same time, it can be a compiler. But a really interesting fact that PHP is both of them, and during interpretation of our script, it behaves like an interpreter. So when we are trying to execute code, PHP first trying to parse our PHP source file, then tries to compile it, and then only on virtual machine we are executing in a Zen engine machine. And only after that we will receive an output. But on the second run, when we run the same script again, we can see that opcache is used, and we are not more interpreting, but we are running. And in this way, it behaves more like a compiled version of our application. And compiled version of our application contains opcodes. It's a special feature in PHP to put your code into machine instructions, and these machine instructions compile it only once and cannot be changed in runtime. When we are looking at representation of opcache, it's a fixed size memory block in memory of PHP, which contains only binary structures, no more classes or AST. It's optimized for execution. And important fact that structures are immutable, so we cannot change them in runtime. And this opcache is append only, and we are appending new structures on top of it. But these structures contain only important information from our files. For example, definition of our functions, definition of our classes, script in the form of opcodes, and some information like intern strings, immutable arrays, and information about PHP version. These immutable structures are really important for PHP because they're immutable, and we can just copy-paste them and run it in runtime, and this increases performance of PHP a lot. But at the same time, we cannot modify this information. We cannot add new method. We cannot delete new method from a class. we cannot change inheritance structure, for example, to add new interfaces, to remove interfaces. And we also cannot modify existing behavior of compiled classes. Of course, it's possible to do it with some powerful extensions like runkit or uops, but we are not really want to use one of them.